Several at the Starknet Foundation, and I'm also one of the co-founders of the Phoenix Kit. I might have met some of you at meetups. So, disclaimer: I don't actually work on chain abstraction as a separate topic. I think chain abstraction is kind of the logical adoption to bringing the next billion, whatever million users into the Web3 space. But what I'm going to be presenting is a very cool framework that I think Yash briefly spotlighted called the Cake Framework. And in the Cake Framework article, which I researched in the last 5-10 days before having to give this presentation, there is a lot of cool stuff that I think we can build, and maybe I'll just throw light on that if it inspires some of you to build some cool stuff in the upcoming hackathons or stuff like that. So this is the POE that I'm going with, okay? And so yeah, I asked ChatGPT to give me a diagram of a simple dApp built in Ethereum, and it gave me this. It seems like this is the funda everyone is following, that the journey shapes us more beautifully than the destination, and seems like for devs and for users alike, the journey to actually get to Web3 is super hard. It's just too many things. Like literally ChatGPT gave me another complex diagram and I was like, can you simplify this diagram for me? And then it gave me this, right? You could see that just to build a simple cross-chain application, you have like it considers Ethereum as one of the biggest things, and then you have smart contracts, you have some other cross-chain elements, and you have some wallets, and you have Bitcoin or whatnot, right? So APIs and everything. So there are just too many things that are required today to build a cross-chain application successfully. So from even from a dev perspective, if you are building something, like think of a game, right, which should work chain agnostic, where think of a betting environment where people can just come and bet in any token that they have, and then be able to seamlessly sort of get the results of that application. Your application at the back end could be running on any chain, right? It shouldn't matter to the user. But the user has to, the developer has to jump through a bunch of wallets, chains, and then as you go deeper, then different consensus protocols, how do you settle, etc., etc. There's just too much friction to build stuff. Can devs do something? Yes. So there are a lot of solutions that are coming up. I think Octo, Yash already spoke about this. One SDK, multiple offerings, and a lot of other players also in this space trying to do the same thing. Universal Common Paymasters. There is a talk about particle network, I think a bit ahead in the schedule. But they are doing a lot of these universal products. So Universal Common Paymasters is a very cool idea. I don't know if anyone else apart from Particle Network is doing it, but basically a paymaster deployed on different chains that could instantly pay for your gas fees. I don't know if there's anything seamless that's been built yet, but could be really cool if you could get that adopted soon. And then you have different smart wallets with social recovery passkeys. I recently saw a tweet that passkeys is like basically super next user-friendly thing that you could build into your app. I think a lot of smart wallets already have passkeys, but lack the ability to interact with different keychains. I mean, the different chains. So what if you could just have a fingerprint and you could just validate, be able to interact with as many chains as possible just within a passkey, right? I think this is something very cool. There are a few passkey-based SDKs that I've used. There is Zero Dev, there is Pimlico, and I think there is also some other new stuff. But none of them have gained as much adoption, so I think that will be super cool because most of these are very closely related to 4337. So they are looking at account abstraction and then adding a passkey module on top of that. But could you separate the passkey module from the account abstraction module and have the passkey module itself interact with any of the different AA wallets? That could be a cool thing to build from a developer perspective. And yeah, I mean, just the ability to have generic programming languages being able to settle. So I have to throw this in because I work at Starknet, but no, just kidding. But it's fun, right? Like recently Starkware announced that they will be able to build proofs that can settle on Bitcoin. So basically, you see a lot of cats because the opcode OPCAT has got a number. That's it. Nothing exciting has happened. But there is a lot of money being thrown into this research about making Bitcoin programmable. So basically being able to increase the settlement layers. So people who are on those settlement layers could also become your users. Think about it that way, right? So you're making a seamless end gateway or entry point for people who are already part of different ecosystems, but now are completely abstracted from all of that and can just interact with this ecosystem as one black box for them. So some innovations on these lines is also pretty interesting to look into. Okay, so the cake framework is what I want to talk about today. I think it's very interesting and Yash briefly also touched upon it, but so cake is basically chain abstraction key elements. So you are trying to see what are the different things that would enable chain abstraction eventually. So as a developer, you could look at building, improvising any of the things in this space because many of these are broken and need work. So the first one is of course the application layer, you don't have to worry about that. And then you see the permission layer where you see account abstraction, the different wallets, how do you manage these policies, intents. And then the solver layer where I'm not sure if you have heard of intent-based wallets where you send the user sends an intent and then there is a solver. So this ecosystem already exists, but there is a lot of different components associated with that. So when a user sends an intent, the solver solves for that intent and then generates a transaction that supposedly mimics what the intent is supposed to be. So the intent is nothing but the output of what the user wants. So that's the solver layer for you. You have different things in the solver layer. You have the sequencing, you have routing, then mempools like the moment you send, so for example the Ethereum mempool, right? The moment you send a transaction, it goes and sits into a mempool and then different things happen there. Private computation, your proof generation, your ZK proofs and all of that falls under the private computation. And then for different other things you have order flow, inventory, auctions and all of that. A lot of DeFi related stuff also, the solver ecosystem. Settlement layer, this is what I actually work on. So any of your L1s, L2s, all of these actually act as settlement layers. Some of them also have some of the solver layer elements, but not all of them. So oracles for you to, not just external oracles, but also oracles that will synchronize the state between two chains. Right? Think about this. When you're doing cross-chain messaging or when you're doing value transfer across different chains, you need oracles that will sync the state of different chains. There aren't so many good ones that exist, so this could be like a good infra project to build as well. Bridges, we all know there are a bunch of different bridges, but of course there's a lot of security considerations associated with bridges. But if you do need to make sure that cross-chain interaction or token transfers is seamless between different chains, then you do need some sort of bridge architecture which is secure. Data availability, I think we have a talk from Avail this evening as well. So you have different DA layers, so being able to separate your execution layer, your DA layers and stuff like that, all of this in the settlement. Finality, of course your main being able to attest to what the final state is. Availability of liquidity. So this is one of the problems that chain abstraction is trying to solve, where your liquidity is fragmented in different pieces. Proofs, settlement of proofs, and the execution layer. So this is the cake framework. Was written very recently. I'm quite impressed with the amount of work that they've done. And now going to what devs can solve for. So there are a few design decisions that you take while working on these different layers, and these decisions collectively can be taken by a framework, which is what they are calling as the CAF, which is Chain Abstraction Framework. One of the things that you could potentially contribute to building is either build a framework itself, right? that will have or that will consolidate different elements from the different layers and give that framework to other people to be able to build on top of that, or you contribute to building different elements in the framework itself. So when you're building a framework, you have different design decisions that you need to take, whether how do you build the permission layer, how do you build the solver layer, how do you build, how do you build the solver this, the settlement layer and things like that. And this is what I wanted to share is from a dev perspective, how you can build for stuff. So there are 3 things that you will have to consider when you're thinking. So the chain abstraction part is literally all about different chains being able to talk to each other seamlessly, right? At the back end, from a developer perspective. From a user perspective, it's the user being able to give a command and getting some result of it. The result can be yes, positive, right? That your transaction was successfully executed, or no, negative, your transaction failed, right? This is from a user perspective. That we have already spoken about. From a developer perspective, from our perspective, we have to figure out how this command can be translated into a successful execution. That's the success, right? Successful or unsuccessful execution. So you have to consider 3 things. One is low fees. How can you make it happen in the least amount of money possible for the user? Execution guarantee. How can you make sure that the user can 100% gets an execution guarantee? This is actually the most difficult part when you're interacting with different chains, like I mentioned, right? Those oracles that are maintaining the state of different chains. By the time you give an execution command in the first chain and you're trying to synchronize that command on the other chain, the state of any of these chains could have changed rapidly, and the user might be able to do a double spend attack. So this is where you need to figure out how you kind of make this interaction seamless. So can you actually give an execution guarantee to the user? I think that's the hardest part. However, the execution speed is the third thing that's also important. How fast can you get the transaction executed in as low money as possible? And can you give an execution guarantee to the user? Because of course, if your framework is not able to give execution guarantee to the user, people are not going to use it. And the potential solutions that you could do in order. So the dilemma here is that most of the frameworks will have to choose 2 out of these 3. They end up only choosing 2 out of these 3. Most likely it is low fees and execution speed. Most times you are not able to give execution guarantee. Or you do low fees and execution guarantee and you're not sure how fast the transactions will happen. Like it could be 15 minutes, it could be 20 minutes, because you're waiting for the states to be synchronized, right? Or it could be execution guarantee and execution speed and you're charging a lot, right? Because you're going to pay a lot on both the chains for this particular transaction to go through, so that you don't have to wait for synchronization and stuff like that. So if you can think about building frameworks or building products that would solve for this trilemma, that's where I think we can make major progress in terms of chain abstraction. So a couple of things that they have mentioned that you could potentially work on, especially just these 3 things, which are in protocol paths. So like, I don't know if you might have heard of Cosmos IBC, which is where you have the inside blockchain communication, so you can talk to different chains within the same ecosystem. So things like that in protocol paths. Solver aggregation, so when you are trying to solve a particular intent, right, how do you make it more seamless for the user? Something, an analogy is like the trade aggregators, the DeFi aggregators, where it aggregates the cheapest path for you and the simplest path to swap 2 tokens, right? So something like that, you can build a solver aggregator, that there are a bunch of different open source solvers that exist. Can you build an aggregator that will give you the fastest path of execution for yourself? And then your execution competition. So this is more or less like, again, do you have an exclusive solver? Do you ask the solvers to compete for cheapest gas, etc., etc.? So some of these things are something that we can work on from a dev perspective. And this is the last thing that I want to kind of highlight, which is what they have built as part of this article. So some of these things already exist. So like you have CCIP is the one that I would consider most popular, the chain link functions, and then you have the polygons ag layer that's being talked about, IBC being there for a while. You have, for example, solver competition, so you have these different things. Uniswap X is the only thing I've heard of. And wallet control messaging, lot of stuff over here that we can work on. I think it's still very, very like under progress. And then the solver competition. So this was something I found interesting, that you have like Orbiter Finance and Across Protocol which are trying to solve for this. And you don't have anything for exclusive batch auctions. So this is definitely somewhere where you can, fill the gap, but it's going to be, it's cross-chain message call, so it's not going to be something easy, it's not going to be fast, so how do you kind of build out these stuff? But if you see, not looking at the properties, like if you see most of these are like very, very in the beginning layer, and also not as popularly adopted as you think it would. So I think it would be worth doing research in terms of understanding what are some of the drawbacks in this, and if you can build something better. Because even for CCIP, it only covers a few chains. But maybe a cool thing would be to add more support to CCIP, adding more chains to the whole chain link functions and stuff like that. So all of these layers, like all of these six elements of the framework are like up for grabs. Lot of interesting experiments that you could do over here. For example, one of the only example that I am working on, or I can think of from my organization, is a generic programming language. Like for example, we use Cairo, which is the programming language for Starknet, but it is a general purpose provable programming language. So you can actually take that to build provable programming and be able to settle on any layer, ideally. So having more generic stuff, like think about Rust. Rust is a general purpose programming language, right? It just requires some sort of execution environment. So can you start using existing things? So there are two ways. One is you build new stuff in the gaps, and second is you use existing technology to make it more generic. So you are getting one step closer to chain abstraction. So yeah, that's pretty much what I had. I'd slotted in 10 minutes. See, I didn't have a slide for questions because I don't work on chain abstraction. But I'm happy to like discuss like what do you think are the cool things that you want to build, and like I'm happy to support anyway if I can. Yeah.
Anybody with some questions or thoughts? I think. Awesome. Thank you so much, Gyan. Folks, the next half of the event is the Builder Showcase. Most of these speakers are here. We'll be taking a short break for the next 5-10 minutes, so please feel free to get some water, hit the restroom if you want. And we will have the builders coming in speaking about the projects. We have DevRels and head of products and engineers here to talk about the projects as well. And one of the DevRels from Particle Network will be joining us via Zoom too. So it's one of the exciting part of this event. Please take a break and we'll come back in 10 minutes. Thank you.
Now we're starting.